Hello class, welcome to 3.1 part 3. This is the last portion. It's a rather short one. It's called the applications using the definition of the derivative. There's only one objective. We look at a few application problems. All right, we'll begin with the first one. A vehicle is moving, this is moving really fast, in tune with the problem. A vehicle is moving in a straight line with position function f of t equals 2t squared. Look at that. That was supposed to be a 2t squared. Let me erase that. 2t squared plus 8t. Okay. For 0 less than or equal to t less than or equal to 5, where distance is in feet and time in seconds. Use the limit definition of the derivative to find the velocity of the vehicle at time t equals 3. So I'd like us to do a quick sketch of the scenario. Okay. A vehicle is moving in a straight line with position f of t. So this is the position. You want to mark this as f of t, your y-axis. And your x-axis is t because time is the independent variable and f of t depends on t. And time is in seconds. And distance is in feet, right? Distance. And so we are trying to, this just helps me to put the variables in their right positions. And then we are told to find the velocity. Velocity, they didn't say explicitly derivative or anything like that, but you have to kind of understand what velocity is. Velocity is actually speed, right? Speed is distance over time. In other words, if you are converting this to math, to slope idea, right? Speed or the rate is nothing but the difference in the distance over difference in the time. And that helps you to understand that you're actually trying to find the derivative, right? So if you took the derivative, which is the derivative, okay, the idea of derivative. So now we have, what was it? The time is at, the derivative at t equals 3 is what we're trying to find. So now we go back to our f prime formula. F prime of a is limit h approaches 0, f of a plus h minus f of a all over h. So our a is 3 here. So it's f prime of 3 minus f of 3 over h. Your f function, let's go back, it was 2t squared plus 8t. I don't know why it does that. Your h function was 2t squared plus 8t. So I want to do the calculation by the side so it doesn't take too much of our space. So f of t is that, right? For convenience, we write it down here. 2t squared plus 8t. Right? So f of 3 plus h. In the place of t, I have 3 plus h. So please remember that wherever you see t, you're going to plug in 3 plus h. Okay. This requires a little bit of calculation. So let's go ahead and do that. Okay. So again, you could multiply it twice and FOIL it, or you could use the a plus b whole squared formula. So that's going to be a squared plus 2ab, sorry, that will be a 6h, plus b squared, which is 8 squared, plus, distribute these, or, I'll do it in the next step perhaps. And that will give us 2 times, distribute the 2 to each one of them, right? 18 plus 12h plus 2h squared plus 8 times 3, 24 plus 8h. Combine all the like terms you have, okay, and see what happens. And I'm triggering something that is making it roll over. Sorry about that. Okay. All right, what do we have here? So you have 2h squared plus 12h plus 8h, 20h, okay, and 18 plus 24, 42. You got that. We can also find f of 3. Look at that. Yeah, there's room for it. Okay, just create more room. F of 3 would be 2 times 3 plus 8 times 3, right? I'm opening those shells so that I can plug in 3 this time, because in the place of t, I have 3. So now you have 3 times 3, 9, 9 times 2, 18, plus 24, which is 42. Okay. So I can come back here and simply enter those values. F of 3 plus h gave me this information. So let's say 2h squared plus 20h plus 42 minus f of 3 was 42 here over h. So that cancels those two off as we would expect, because those were non-h terms. And then limit h approaches 0, pull out the h. So I have 2h plus 20 divided by h. And the h's will cancel off again as expected. And in this next step, you can already evaluate the limit by plugging in h as 0. That leaves us with 20. So because this is a word problem, you just don't stop at 20. We have a context. So you come back and say f prime of 3 is 20. The distance was measured in feet, so, and the time in seconds. So 20 feet per second, right? So if you want, you can go further and, use that sentence and say the derivative or the velocity of the vehicle at time 3, at time t equals 3. So I'll say this is the velocity, the speed, right, of the vehicle at time t equals 3 seconds. Okay, so this vehicle was traveling at a speed of 20 feet per second. And that's interesting because now you're able to use it for real life circumstance where you're really finding the speed. Here's a similar problem. A vehicle is driving along a straight road. Its position function is given by s, which is f of t equals t squared, where s is measured in feet, and t is measured in seconds. Use the definition to find instantaneous velocity of the vehicle at t equals 4. Just for variety, I'm going to give you the notation, because here they said s is f of t, right? We know velocity from the previous example. We know that velocity is what we're trying to find. So in physics, we use v. So v is actually your f prime of t. But then they're saying t is given, we want to find the instantaneous velocity at time t equals 4 seconds. So this is exactly what we are asked to find, f prime of 4. So for variety, we're not going to use the h notation, okay? Let me use the x notation. In this case, we don't have x, we have t in its place, right? So we had f of x minus f of a. Instead, we now have f of t minus f of a all over t minus a. And therefore, what we had as x approaches a would now be t approaches a. Okay. All right. Your a is 4, so the f prime of 4. So limit t approaches 4 f of t minus f of 4. Remember, a is 4. Don't plug in for t. Plug in for a. That is t minus 4. All right, because this is, again, a simple function, I will do the substitution right here. I don't have to do it by the side. So this will be 2t squared, the very function itself, minus 2 times 4 squared, because now t is 4. That gives us limit t approaches 4, 2t squared minus, you have 4 squared, which is 16. 16 times 2 is 32, right? I just want to save a step. So what I'm going to do is go back here and factor out the 2. You can see that very clearly, right? You can see the 2 here and the 2 here. That'll be easy for me just because I know that I could factorize the t squared minus 16 using difference of squares. And that will be useful in eliminating the denominator. 2 times t plus 4 times t minus 4. Remember, this did not use the h, so you don't have those inbuilt tests for us to know that the h has to cancel off. One thing we know, your t minus 4 has to go away, because if you kept it as t minus 4, when you're ready to apply the limit, it will become 4 minus 4, 0. So that is, you can consider that as an inbuilt check. You will be using mostly algebraic techniques to handle that. T approaches 4, 2 times t plus 4. Now we're ready to plug in for t as 4, which will give us 2 times 4 plus 4, 8 times 2, 16. So once again, you go back and, because it's a word problem, and you know that distance was measured in feet. So I'll just put it by the side here. V of 4, right? Velocity at time 4, which was your f prime of 4. I'm bringing these new notations because they're in physics. You don't have to use the f prime notation necessarily. You could also use the v. And so this is helpful. 16 feet per second. And if you were to explain this in words, you go back to the question and pull the sentence from the question. It said, find instantaneous velocity of the vehicle. So this is the instantaneous velocity. And again, remember, another name for instantaneous velocity is derivative. And therefore, we have looked at a few examples on applications of derivatives. I hope you enjoyed 3.1. I will see you with the next section, 3.2.